back to our channel Sanjay Ideas. So I am back with the new topic, moving iron instrument. One of the most accurate instrument used for both AC and DC measurement is only moving iron instrument. There are two types of moving iron instruments. One is attraction type moving iron instrument and second one is repulsion type moving iron instrument. In this video we are going to discuss about what is the attraction type moving iron instruments and talk developed by attraction type moving iron instrument and advantages, disadvantages and applications. This is the diagram of attraction type moving iron instrument. The working principle of attraction type moving iron instrument is based on the magnetic attraction. An iron piece is placed near a magnetic field, then magnetic field will be produced by an electromagnet. This is the working. Now coming to construction, it consists of a fixed coil and moving iron. A moving iron is made up of soft iron, is mounted on a spindle. This is the spindle. The coils are wounded with a number of turns that depend upon the range of the instrument. The pointer is mounted on a spindle which consists of the controlling torques are provided by springs of the instrument. This instrument uses air friction damping to damp out oscillations, which consists of a movable piston made up of aluminium placed in an air chamber. This is the piston and this is the air friction damping. This is the chamber. Since operating magnetic field is produced by the coil winding is not much strong, the eddy current damping, which uses permanent magnets, can distort the main field. So by using eddy current damping, the magnets gets repelled. So we are not using eddy current damping, and also fluid friction damping is also not used. The moving iron instrument is made up of sheet metal for obtaining a uniform scale. Coming to working principle of attraction type moving iron instruments, whenever a current is passed through fixed coil, then the current direction will produces a magnetic field. By magnetic induction, the moving iron gets magnetized. This moving iron will get magnetized with the fixed coil. So the north pole of the moving coil is attracted by south pole of fixed coil. Thus deflecting force is produced due to force of attraction. Since the moving iron is attached with the spindle rotates and the pointer shows over a calibrated scale. But the force of attraction depends upon the current flowing through the coil. This is the working and construction of attraction type moving iron instrument. Now let us discuss torque developed by moving iron instrument. Let us know what are the parameters required for torque developed. Theta equal to deflection corresponding to a current of I amperes. Next, TD equal to deflection torque in Newton meters. L equal to inductance in henries. I equal to initial current. Di equal to change in inductance. Di equal to change in current. D theta equal to change in deflection. Let the current increases by di, then the change in deflection is theta plus d theta. There is a change in inductance. Now we have to find the EMF induced in the coil. E volt, E equal to d by dt Li. L is the inductance, I is the initial current. So we know differentiation of Li. We have to find differentiation of u into v formula. U into dv by dt plus v into du by dt. If we consider u, differentiation of v, plus if we consider v, differentiation of u, we have to use this formula and apply here. Then we get L into di by dt plus I into dl by dt. This is the equation 1. It is measured in volts. Multiplying by I into dt in equation 1, we get E into I into dt equal to L into di by dt into I into dt plus I into dl by dt into I into dt. This is the equation 2. We know E into I dt get cancelled here. Consider as equation 2. Initially, the energy stored by the instrument is half Li square. Here, two forms of energies are stored. One part of energy is stored in inductance and remaining energy is converted into mechanical energy, which produces by deflection. Now, let us know change in energy stored formula. Change in energy stored equal to final energy minus initial energy. We know initial energy is half Li square. Final energy, we have to find the final energy. Now final energy is half L plus dl, the new inductance, and change in current plus initial current whole square minus initial energy formula half into Li square. Now we have to apply A plus B whole square formula. We get this. Now we have to take common as half L plus dl I square plus di square plus 2i into di minus Li square. So we have to multiply by these two. Then we get half L into I square, Li square plus dl into I square, dl into I square, L into di square, L into di square plus dl into di square, dl into di square plus L into 2i into L di plus dl into 2i into di dl minus Li square. By simplifying these, we get Li square get cancelled, half dl I square. By simplifying above equation, we get half 2 into Li di plus I square into dl. Now by dividing these two, Li di plus I square dl by 2. Now mechanical work done to move the pointer by d theta equal to dt td into d theta. The work done, mechanical work formula. By law of conservation, by law of conservation of energy. In electrical energy supplied equal to increased in storage energy less mechanical work done, and also input energy equal to energy stored plus mechanical energy. We have to find this LI get cancelled, and half I square DL will come to LHS side. Then half into I square DL equal to TD into d theta. Then TD equal to, we have to find TD value, then half I square DL by d theta. Its steady state condition TD is equal to TC. Then TC equal to K, spring constant, into theta. TD equal to half I square DL by d theta equal to K into theta. Theta equal to half I square, half 1 by 2 into K I square DL by d theta. Then we know theta equal to proportional to I square. When the instrument measured in AC, then theta is directly proportional to I square. Coming to advantages of moving iron instruments. It is cheap in cost, less frictional error, and simple construction, and it is used for both AC and DC. Coming to disadvantages of moving iron instruments. Scale is not uniform, and it consumes more power than permanent magnet and moving coil instruments. Calibration is different for AC and DC operations because this instrument can use both AC and DC. It suffers from eddy currents and hysteresis errors. These are the disadvantages and advantages of moving iron instruments. Next, we have to discuss applications. Used as an synchroscope and moving iron power factor meter, moving iron voltmeter, heavy current moving iron instruments. Where the current is high, the moving iron instruments are used. Once go through syllabus and previous lectures of measuring instruments. The links are mentioned in the description. If you like this video, please like, share and subscribe to my YouTube channel, and don't forget to click on bell icon. Thank you. Keep watching. Bye bye.